So we are starting with the functions. People that have their notebooks, I'm seeing that they'll have them. They'll be pretty appreciated that you have them ready and set up. Remember, you're bringing them every single day. Right? Huh? Yeah, we'll glue them later. So, today, we are working on lesson 7.1, relations and functions. So, first thing, our warm-up, we're going to look at these two little graphs, these mapping diagrams, and it says, describe the relationship between the input and outputs of each diagram, then complete the diagram. Is there more than one thingy? Some of the stuff that we'll do up on the board will not be in your notebook, and that's okay. It's going to be part of you focusing. That's part of what you're learning from. So when I look at A, I put in 1 and 1 comes out. I put in 2 and 4 comes out. I put in 3, 9 comes out. I put in 5, 25 comes out. What could be happening here? What is the relationship between input and output? Right?
You multiply the input by itself.
Yeah, we're multiplying the input by ourselves. The way we kind of show that is we just say x squared. And that just means when you have a numerator or an exponent to something, it just means how many times each times that number by itself. So I do 1 times 1, 2 times 2, 3 times 3. So if I put in 8, what would come out?
64.
Good. 64 would come out.
9.
If I put in a blank number, 81 came out. 9. Now the second part of this was, on this first one, is there more than one possible answer?
Yes.
What that means, if I put a number in, can more than one number come out? So when I put in 2, and I do a relationship, can the output be anything besides 4?
No.
No.
Can it be? It can be 8. So if I put 2 in, 2 times 2 is 8.
Wait a second.
It could be
It can only be
negative 4.
No. Is 2 times 2 negative 4?
Negative 2.
So on this one, you will see that there is only one output for every input. Or better said is, every input has only one output it goes to. It does not go more than one. If I look at the second one though, I put in a blueberry and blue comes out. We put in 11, yellow comes out. I put in an apple, yellow comes out, or red comes out, or blank comes out.
Green.
Why green?
Because there's green apples.
Okay, so before we shut out, let's hear this.
Brown apple.
Joe. Okay, now, you came up with green, and you're right, apples are yellow, red, and green. So what would be the relationship between the input and the output?
The fruit has the color.
Color of fruit.
They only sell red ones here.
No, they got.
Oh, friends, I'm not going to have us keep just shouting out comments because we want to have our voice heard. I'm going to have to mark your planners for that, and then I'm going to send you out. Remember, when I send you out, the next day you come to lunch and we have to send the email home. Because we're distracting other people's learning with our silly jokes. So, focus on this for me. Now, on this one, we showed that green is an output, and I see that there's apple went to green, but there's another one that only goes to green. What could I put in that would only go to green? It can't be any other colors. Well, we said grapes in the last class, but someone said we could have, hold on. We could have purple grapes, we could have red grapes. So grapes would work.
Lime.
Grass is not a fruit.
Lime.
Lime a fruit?
Cucumber.
Yes, it's a lemon.
It's an olive.
Oh my god. Kiwi.
All of them say a black
Watermelon.
Have you ever
Block
heard me say it?
Oh, this has to slow down. I heard someone say it over here.
Green? I mean, the outside's green.
I said it. I said lime.
So we said
I said lime, and that's why you said lime.
So, gentlemen. So we would say lime and it comes out green. Are there other things we could put in there? Yes, that's okay. But on this one, is there more than one possible answer for inputs? Yeah. We see that with the apple. We have red, we had yellow, we had green. So on this one, our input had more than one output for it. If you open up your foldable on that very first page, you see the vocabulary. Up at the top, here's the words that we have to understand. Ordered pairs, X, Y. They can be used to show inputs, which are the X's, and the outputs, which are Y. So if I wrote down coordinate points 0, 1, 1, 2, 2, 4, the X is always my input and the Y is my output. We show that here in a relation. A relation pairs the inputs with the outputs. And it can be represented by ordered pairs, which is what we just saw. 0, 1, 1, 2, 2, 4. Andrew, follow along with this. But then we can take those ordered pairs and we can put them in a mapping diagram. This is a mapping diagram. You have your input, you make like this circle, you put your input inside, and you have your output, and you put them inside, and then you draw your line. Whatever input matches with the output. So on this one, this ordered pair was 0, 1, so 0 went to 1. 1, 2, 1 went to 2. 2, 4, 2 goes to 4. I know for a fact today you are going to have to go from a mapping diagram and write out the coordinate points. And it's very simple. The input is your X, the output is your Y. We're going to look at example 1. It's up here on the board. We're going to see if we can figure this out. It says, for each diagram, how many outputs does each input have? And this is a mistake a lot of people make.
Do you have a USB port though?
For an iPhone?
Yeah. iPhone,
Alright, so if I look at these two, I see I have play A and I have play B. So we're going to end up having two answers. On play A, the input is the tickets, the output is the cost. Input 1 came to 8. 2 tickets cost $16. 3 tickets cost $24, and 4 tickets cost $32. This is on your first foldable, so everyone should be opened up. Guys, you're on the homework one. You need to be on the other one. That's homework. We're looking at our notes. Okay, so for each diagram, how many outputs does each input have?
2.
Let's look at A. On play A, how many outputs are there for each input? 2. 4 is the most common answer, and that is wrong.
Dang it. Is there 1?
There are not 4. There's 4 outputs listed, but the question said for each input, how many outputs are there?
There's 3. Red.
1.
In your notes, you can.
1 output. 1.
There's 1.
What? He gave me. I was.
When,
I swear he's. I said that.
when I look at 1,
I sure said 1.
when I look at my input, it only goes to 1 output. 2 only went to 16. 3 only went to 24. 4 only went to 32. I only had 1 line coming off my input number. So for A, we will say 1 output per input. Play B is going to be a little bit different. Go ahead and look at play B. How many outputs are there for each input? Blake?
Well, for 2 and 3, there's 3, and for 1, there's 2.
Partially right. There's 4 for number 3.
Oh, there is.
So if I look at 1, I see it goes to 4 and 8, so it had 2. For 2, it had 8, 12, 16, that's 3. For 3, I had 12, 16, 20, 24. So we're going to say our output varies from 2 to 4. There's a big reason we're wanting to notice this. I don't know So the big thing we're noticing here is play A, every input only matched to one output. On play B, every input had more than one. 2, 3, or 4. On number 2, describe the prices of tickets for each play. So if I look at play A, how much should one ticket cost me? What does
$4.
a ticket cost? Nope.
Depends on how many people you have.
For play A, how much does a ticket cost to go to the play A?
Oh, $8.
How'd you get $8, Brandon?
Because 1 equals 8.
One ticket is 8. So on A,
Oh, no, we're talking about play B.
we're gonna say $8 per ticket. We could find that because, like Braden said, I saw one ticket was 8. Then we could look and just see what's the relationship there. 2 to 16 is times in by 8. 3 to 24 is times in by 8. Or you could have went the opposite way and divided. 8 divided by 1 is 8. 16 divided by 2 is 8. So we know that it costs $8 per ticket. How about plan B or play B? Nathaniel?
It's like
Say it again. It varies from $4 all the way to $8. So in our play B, it varies the cost. Sometimes it costs $4, sometimes it costs more. And it went all the way up to $8. Reason it's probably varied is maybe it's an adult and a youth ticket. Maybe it's at a concert and you go closer to the stage, it's a better price. So either way, it's fine. On number 3, it says a person buys 4 tickets for each play. Okay, so I'm going to buy 4 tickets to play A, and I'm going to buy 4 tickets to play B. Can I determine the cost of all tickets? So let's first look at A. Can I figure out how much it costs to go to play A?
Yes.
How much is it going to cost me to take 4 tickets?
$32.
$32. Each ticket was $8. So 4 tickets times $8. It's going to cost me $32. On play B. So my cost is going to, is it going to be a set price or is it going to vary?
Vary on what day it is.
So I'm going to say my cost for B is between what?
$4 to $24.
Between $4 and how much?
$24.
32.
How'd you get 32? Who said it? Okay, why 32 though?
Oh, because you're taking 4 people.
Because I'm taking 4 people. And our cost, so I did 4 times 4 would have cost me, our ticket price should have varied between, we wrote that wrong, I'm sorry.
Oh, dang it.
Should have been $4. Ticket price varied between, no. I said that right, I'm sorry.
Oh.
$4 and $8. I'm looking wrong. To buy 4 tickets, it's not going to be between $4 here. If 1 ticket costs $4, how many can 4 tickets cost?
8.
16. So we had to have that minimum along. So we said at the bottom one, 4 tickets, the lowest was 4. The highest is 8. So 4 times 4 is 16, and 4 times 8 is 32. So our cost is going to vary between $16 and $32. Can I determine the cost of all 8 tickets then? No, I cannot. So for this part, no. Play B varies. With the information we have, we do not know, Andrew. I want to mark your planner, but you're kind of being off task. It varies. So no, I cannot give you a definite price for 8 tickets. Okay, this is all going to come back together here real soon. Let's go to A and B real quick. This is like what you will do on your homework today. They gave me a mapping diagram. On A, I have 1 to 3, 2 to 6, 3 to 9, 4 to 12. Can I write the ordered pairs for this? What is one of my ordered pairs?
0 and 1. 1 and 3.
We're on A.
1 and 3.
1 to 3. So I'm going to write 1, 3. What would be the next one? Tyler, what would be next? If 1 went to 3, so 1, 3, what would be next? 2, 3. Or 2 what? 6. What would be next? Like
3, 9.
39.
And what about the last one? Natalie?
4, 12.
4 to 12. Okay, what about the coordinates for B?
0, 1.
Okay, we have 0. Does it go to 1?
0, 1,
0, 0.
Oh,
Good.
1.
0 went to 0. Then
2, 1.
2
You
to 1.
Negative
2 to negative 2.
Yeah, you did.
And
4, negative 8. Yeah,
That's the joke.
Andrew, come sit here. I know, that's part of the problem. You're not doing it.
Yeah, that's the problem.
Alright. What do we notice on the first one? Our input only goes to one output. If I look at my second one, and I look at my coordinate points, we can see here that 2 went to 1 and a negative 2. So my input went to 2 numbers on that one. If I just looked at coordinate points, I would look at this. I had 2 go to 1, but then I would say, wait a minute, but 2 also went to negative 2. This is important. This is what we're going to discuss real soon. We're getting close to tying this all together. But we need to keep realizing that some of these we've seen, our inputs only go to one output, and other times our input went to multiple outputs. And there's going to be a problem with that. Let's see if you can get this one. This one's a little tricky. If I look at my input, I have Phoenix, I have Denver, Jeff City, Juneau, Lincoln. Do you know what those are? Capitals. So these are capitals. Now, when Phoenix goes into this function machine, it came out to Arizona. Why?
Ooh. Because it's Phoenix, Arizona.
Okay, so Phoenix is the capital of Arizona. If I put Phoenix in the machine, can any other state come out?
No.
No, because Phoenix is only the capital of Arizona. When I put Denver in,
That's Colorado.
it came out to Colorado.
If you put
If I put Jeff City in,
Missouri.
Washington.
Missouri, Juneau goes in. Very good.
Kentucky.
Alaska.
Alaska.
Nebraska.
And Lincoln goes in.
Nebraska.
You just a rainbow.
Well, and I did switch colors. And why did I switch colors, you think?
Because
Show
you
you
want
which one goes to which one.
Yeah. Showing.
they're all the
On
same.
this one.
Did I get it right?
Nebraska.
What did you just say?
New England.
On this one. On this function that we're looking at, our input, Andrew, our input only went to one output. An input did not go to 2 different outputs. That's important. Question?
Of course, that's the question.
So how about on this one? My input is Missouri and Kansas.
That's the state.
Andrew, I'm gonna have you sit here instead.
I was about to say they're probably working.
Nope, right here. Alright. Now on this one that comes in, I'm gonna have Missouri, Kansas, Nebraska, Iowa, and Alaska. But this time, when I put Missouri in, I'm gonna say Kansas City came out.
States and cities.
So what about Kansas?
Lake of Ozarks came out.
Nebraska.
What the heck?
Nevada.
Columbia came out. What do you think is the relation?
States and cities.
Alright, so it's like
Local areas.
one
You
state, whatever it's called, the function comes out with that city.
But Lake of Ozarks is in a city.
No, like it's like places in that. Major places in the.
Good. So places to visit.
I would tell you.
So on this one,
I went to Kansas City.
when I put Kansas in, what might come out? Lawrence.
How do you know that?
How do you
Lawrence. Oh.
Topeka, Iowa.
She studies her capital.
Topeka.
I just
Oh,
everywhere.
Remember, is this
Jayhawk.
capitals?
No.
These are locations.
Spots.
You might have said one of the things that came out could have been anything else in Kansas. Maybe it was
California, Kansas.
where the Jayhawks play.
That's
For the
Lawrence.
college.
Ooh, I want their
The actual
baseball
stadium,
field.
you could say.
Wichita.
So we could be more specific on this.
Good job.
Bro. Don't even say
Okay,
it.
in your foldable, the page right on top of where your foldable is, in your notebooks, you should have an orange page that we glued. It says definition of a function.
I don't have a one thing.
We don't have an orange page in it.
You should.
It's low-key on the back of your paper.
Really?
Down on the tag.
I just did
Isn't
it.
it high
That's your
school?
second
Or just
spot.
outside?
Huh?
Grade it. Yeah. I thought you were the one that said. I thought you were the one that said New England was a state.
No. Okay. Alright, so on this one, definition of a function. What we need to write down, this is key to today's homework.
Today's homework.
Key to today's assignment and homework. It says 1. Function. A function is where each input has one and only one output. You need to copy this into your notebook. Damien, where's your notebook? You need to have it open and be following along. Riley, where is your notebook? Why are you not copying this into your notebook? I want all the rubber bands put away because I'm going to find these lost and left out. Then I'm going to be staying afterwards and we'll be emailing home. Because they're probably wondering why you need more bands all the time. Okay, so definition of a function. A function is where each input has one and only one output. For the characteristics, we're going to write down what we would do to test this. It's called the pencil test.
Oh, I remember that.
You write that out?
Jordan, let's go throw that away, please. Okay, the pencil test. What this is.
That's me. We know. It was fun.
Alright, on this pencil test, what we do is, you can draw this in your notebook as well. But all you do is you look at your line and we're going to work left to right. So write this under your characteristics so you can do this. You're going to look left to right on this line. So I put my pencil vertical. And I start working left to right. And I can see, if you can see on my board, that shadow crosses my line only at one point at a time. So I might say it crosses my line right there. But that's only one point on my line. If it's crossing my point only at one place, I can call this a function. And remember, our function, we could do our input, output, it gave us coordinate points, and then we can put them on a graph. The second one, if I do this pencil test, left to right, I'd have two spots where it hit. So I noticed that this one has two places it hits. If it hits, I would say not a... Charles, let's just put that away right now so you're doing this. I'm not worried about you stapling and playing with the stapler right now. Just put it down and follow with this. Charles, thank you for not arguing with me.
Yeah, I know, because it was fucking.
Not a what?
Not a function. It is not a function, and we know it because that pencil test, it crossed the line at two places at the same time.
No.
Remember, our input can only have one output. And on this one, this would have been our x was our input would have been like -2. And -2 would have went to like 2 and -2. Input can only go to one output. Now, can two different inputs go to the same output?
Yes.
That's okay. I can say an input of 1 goes to 0 and 2 goes to 0. That is still a function. As long as the input only has one line coming off. Here's our examples. We're now tying this all together to see if we can figure this out. On this first one, -9 went to 0. -2 went to 5. 5 went to 10. 12 went to 10. Did my inputs only go to one other number?
No.
Yes. Yes.
Yes. 9, -9, only went to one number.
0.
-2 only went to one number. 5 went to one number. 12 went to one number. It's okay if our output shares, but our inputs have to be independent. They can only go to one place. So on A, we would call this a function. A is a function because our input numbers only went to one output. They only had one that they went to. Now, on B, do my inputs only go to one number?
No, 0 goes to 2.
Okay, -2 went to only 4. -1 went to only 3. But 0 said I went to 5 and 6. If my input went to two numbers, not a function. So let's see if we can figure these out. We're going to look at our other examples we've already went through. Everything that we've been doing, we've been talking about, let's see if we can identify it. This function machine, Missouri went in, Kansas City, Lake of Ozarks, Columbia all came out. Kansas went in, Lawrence came out, Topeka came out. Is this a function?
No. Yes.
No. Because my input went to multiple outputs. So we would say not a function. Okay, I put my capital in. Phoenix went in. Arizona came out. Denver to Colorado. Jeff City to Missouri. Juneau to Alaska. Lincoln to Nebraska. Is this a function?
No.
Yes. Every input only went to one of the outputs. So this is a function. A. We looked at this. Is A function?
Yes.
Yes. If we look at our coordinates, here's the nice thing. 1 to 3, 2 to 6, 3 to 9, 4 to 12. I see in my x's, I never repeat my x. Never repeat my x. So, it is a function. Is B a function?
No.
We highlighted 2, 1, but 2 also went to -2. Ricky, I'm about to mark you down. So this is not a function. Which play? Don't shout it out. I do not want you to shout it out. You shout it out, I'm going to mark you because you're being disrespectful. Which play is a function? Don't shout it out, raise your hand. Which play would be a function? Cohen? A. B is not a function. Okay, here's what you're going to do today. You have 2 assignments. One is going to be worth Starbucks tomorrow. Damien, listening. One of them is worth Starbucks. The first one that's going to be worth Starbucks, so I will not count it as late tomorrow. It's good practice, but I'm going to give you Starbucks and give you up to 10. So, what you're going to do, I'm going to give everyone this little piece of paper. What you must do with it. In my notebook, right here on this page, I'm stopping my teaching because I have people just talking. In my notebook, we had definition of a function. I'm going to go ahead and I'm going to make it say function, not a function. When you cut these out, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. You will cut all 16 out. There are dotted lines where you can cut. That's a kindergarten process. And you're going to glue. Where do they go? Does it represent a function or not a function? I'm going to give anyone that hasn't glued in tomorrow a Starbucks for everyone they have to correct. But I have to see it before we start. Your actual assignment that is definitely due tomorrow, that will be considered late work if you do not do it and it goes in as a 0, is in your notebook. You turn to your homework tab. This is glued in there. You are doing 7.1. Okay? 7.1. Is that this?
Yeah.
No. 7.1. There's 3 questions. On number 1, there is multiple things you have to do, but this really should not take you more than 5 to 10 minutes at the most. But you have to come to class to get completion and you see that you've done it all. On number 1, Charles and Dylan, I'm trying to go over your homework for you. On number 1, list the ordered pairs shown in the mapping diagram. So you have to write each one of these, write the ordered pairs out, and then is it a function? So you write function, not a function. Second one, describe the relationship So what's the relationship from input to output? And then fill in the blanks. There's a couple blanks. And the last one, you're the teacher, you have to explain what was the mistake. So, 2 things. 1, 7.1 homework. And 2, gluing these in.